Hello, good day. I'm John Levi Gutierrez, and I'm here to present about the assignment with regards to emotion detection on images and photos. So, for my next slide is my presentation overview. So, this assignment requires to answer the following questions. How each program works, how the program identify emotions and images, what are the universal emotions present in the dataset, and what are the learnings in the program. Then the part 2 would be the screenshot of all the programs and the outputs that run on the program. So let's start. So how each program works. So the first program uses the convolution neural network, or the CNN. Using the given datasets that was set into desired format using the image generator in Python for the image processing. So the datasets runs through 4 layers, and that will undergo process of convolution and pooling. So convolution and pooling were used to clearly identify the small details per image and to easily compare uh, each layer and the identity of the emotions of every image. So it identifies the details of layers which runs through a Latin function to be arranged in order. So they can get accuracy to the data that run through 50 number of passes. So the data pass into 50 number of passes through TensorFlow function. So the first program uses the TensorFlow function of the Python library. So the TensorFlow function is a library in Python that uses a uh, complex computational complex computations, and it has can compute. It is used to show the nodes and the representations of a neural network in the program. So on the other hand, the second program uses the libraries of NumPy to produce a deep learning framework. So this program uses different functions of operation to clearly identifies each part of the image. So in these programs, it separates different function for every parameter to predict the correct emotions in each image. So to be clearly honest, the program is very hard to comprehend if you're first time to see the program. So it's really hard to comprehend to if you will not uh, look in every step of the program. So I just observed in the two programs, so it used different approach to treat the data set. So the other one is using the TensorFlow. Then the first one is using the TensorFlow, so it has 4 layers. So it gets 4 into 4 layers. So in the process of pooling and convolutions. So the other one is using different functions. So every parameters has different functions. Then I think the first one, the output would be the accuracy of the data in the program. So it will get the output or the accuracy of the data in the program. While the second one, the output would be the loss. So it validates the loss of every parameter. So the lesser the loss, maybe it will become more accurate. So we'll turn into the next slide. So we'll answer the question how the program identifies emotions on the images. So both programs has the same code, which is to predict the emotions in the given data sets. So the first program uses 4 layers of convolution, as I said earlier, and pooling process of each image. Then the data process into 50 times passes. So you will see in the program the word epoch. So that would be the data passes in order to calculate the accuracy of the data. So the second program, in the other hand, uses different functions to clearly identify each layer of the image. So this program calculates the value of the loss, which I think it means less loss. So I already said it earlier. Less loss you have, more accurate the prediction will be. Next question that I will answer is, what are the universal emotions present in the data set? So if you will look into the data set, each program for the distribution in the toggle, so the data set contains 48 by 48 pixel grayscale images of faces divided into train and test data sets. So images are categorized based on the emotion shown in the facial expression. So it has 7 unique emotions. So what's that? So we have the happiness, neutral, sadness, anger, surprise, disgust, and fear. So the dataset contains 2 groups of data, which is the training and testing data. So that is how we train the data. So we have trained and testing data, which contains, as I said, the 7 classes, which is the 7 universal emotions. And each class contains a features with 48 by 48 and a grayscale format. So that would be the data set. And the last questions that I will answer is, what are the learnings in each program? So with regards to the first program, I have learned the use of TensorFlow and convolution neural network in Python. So I also learned the use of pooling in the first program. So pooling always get a high number of each layer to carefully compare each layer and predict accurately. So if you will take a look about the meaning of pooling and convolution, so you will learn its functions. So the second program I have learned the use of classes and functions. So this program was very detailed and manually created to clearly see the process of emotions and detections. The process of emotion detection, the program also calculates the loss in order to see the accuracy of the simulation of the emotions on each image. So in this activity, I've used a PyCharm Community Edition. So the problem I'm using standalone editor compared to the web-based editor is you need to manually update the editor. So a part of the program is being complex. So the struggle or the struggle that I have encountered in running the program is, if you will run the program, it will took too much of your time. So it depends also in the system of your system accounts of the computer. So the specifications. So if the computer has low specification, the program will run very slow, and it will take too much time, and sometimes it will crash the computer. So that would be all in answering the questions that that is provided. So I have here some screenshot of my program running in PyCharm Community Edition. So you will see the screenshot. So you will see the screenshot of my first program using the PyCharm Community Edition. So I have plugged the required command in the Kaggle. So I just paste all the commands in the PyCharm. So it would be the output. So it is the output of the program. So if you will see, and if you'll notice that the program, the first output, so it declares that the file that was in training's data has 28,709 images belonging to 7 classes, and found in the test data would be 7,178 images belonging in 7 classes. So this would be the sequential summary of the first program. So including all the parameters. So in this slide, you will see all the parameters, so the total parameters, the trainable parameters, and the non-trainable parameters. So this slide just only shows you about the data passes. So how much data pass into number of process. So you will see that the data passes into 50 process. On the second program, emotion detection with the framework using NumPy. So this one is just my first screenshot, and this is the number of passes that runs through the second program using the deep learning framework. So you will see after displaying all the number of passes, you will see all the epoch loss would be 0.25174, and valid loss would be 0.17083. So if you'll notice that loss is just it has less loss, or the difference between the epoch loss and the valid loss is just minimal, and the loss is considered only 0 point something. So it just shows you that the prediction would be more effective if this is just the loss that was generated. Okay, that would be all of my all of my presentation. Thank you for listening, and God